Welcome to a pre-recorded webinar, IQMS MES Briefing, Increase Visibility and Transparency into Every Aspect of Your Manufacturing Operation, featuring George Cave from SKF Aerospace and Steve Bizot from DelmiaWorks IQMS. We hope you enjoy the webinar.
Hi, this is Steve. I'm going to be doing the MES briefing today. At a certain point in the presentation, I'll be joined by George Cave of SKF Aerospace. He's got some real-life experiences to share with you guys. Manufacturing execution software, I won't read those words. That's Gartner's definition of it. What I will tell you is that I've spent 27 years in ERP, and a lot of that time I worked in ERP for distributors, wholesale distributors, and a lot of times I worked at it in the retail sector. And I had never really heard of MES until about 10 years ago when it was explained to me that in the manufacturing ERP sector, there was this huge middle ground that was defined as MES or manufacturing execution software that actually looked after the shop floor. And that's what we're going to talk about today. A little bit about our MES. First of all, it's native to our ERP system. So if a customer or a prospect has our ERP system, there's a native production process monitoring modules that sit right in with it. And then we also do what we call standalone MES. And this is a situation where a manufacturer is perhaps running a J.D. Edwards or an SAP ERP system for their financials and some of the more front office stuff, but they want a shop floor solution, so they will buy our MES solution and integrate it into that backbone ERP system, and I'll say more about that towards the end of the presentation. MES embodies all the attributes of IoT and Industry 4.0. I've got a slide on that coming up. But it starts with scheduling, and then goes into production monitoring, and then on into process monitoring, and into quality, and MRO, or maintenance and repair and operations. And I've got a slide on each of these topics that I'll cover coming up. So Industry 4.0 is the digital transformation of industrial markets. And the concept was really coined several years back by the Germans, a very proud manufacturing economy. And they felt, they were concerned that they were going to fall behind the rest of the world in terms of their manufacturing prowess. So they started an initiative called Industry 4.0 or Manufacturing 4.0. And it had four main tenets: IoT, the Internet of Things, the interconnectedness of things, using cloud to do the computing rather than having a lot of on-premise computing, moving stuff up to the cloud, a lot of interoperability between material handling equipment, production equipment, and operators, and then big data to look at everything that's happened and everything that was measured and to deduce from that how things could be done better, or if there was an issue, what the root cause of that was. So those four boxes there are the tenets of Industry 4.0, and it's really all about moving from manual manufacturing, semi-automatic manufacturing, to fully informed smart manufacturing. So I noted that MES is at the heart of a manufacturing operation. This diagram, I think, illustrates it very well. Is that the front-end ERP is receiving sales orders, checking for materials, doing the MRP, doing purchasing. And then when you hit the middle, where all of those resources are deployed, you've actually got the shop floor. You've got the workforce, you've got the machines, you're monitoring production, you're monitoring processes, you're showing various documents to the operator about how to do things. Is somebody certified to do this? Is it meeting the blueprint? And then on into the maintenance and repair of the equipment, and over into the quality realms. Those are all shop floor-centric concepts that are embodied by MES. And then once the finished goods are made, you're more into the warehousing and the shipping and the logistics and order fulfillment end of ERP. So if you're buying our ERP product, it runs all the way from the left clear over to the far end of the right. It's a turnkey system with native MES. If you're running a JDE or an SAP backbone, you integrate our MES functionality into the middle of the front office and the shipping functionality that you have native to those things, and we call that standalone MES. So it all starts with scheduling. Customers create demand either through forecasts or work orders or special orders, but it has to be scheduled. And that's the first step in effective shop floor operations. We have a scheduling module. It's real time. It's drag and drop. If you have a schedule suggested by the software and you want to move something around, you drag it over to a new spot, and it automatically rejiggers all the expectations for the other job. The color coding is important. It's a visual indicator. On this screen, red means that machine is down, yellow means it's scheduled for maintenance, green means it's good to go. So there's all different kinds of colors that indicate where a particular piece of equipment is at. We have a feature called Runs Best, where jobs have run on equipment before, and we've determined that they run much quicker on this piece of Cincinnati equipment, so let's schedule that there. Capable to Promise is a nice feature. This allows somebody sitting at a desk to receive a call from a customer. Customer says, I need 5,000 bumpers, and you key that into the computer, obviously, and it checks all the raw materials, labor, machinery, and suggests to you when you could make those 5,000 parts available to the customer. And if you can't, it tells you why not and what steps you need to take to get the raw material, labor, or machinery available to meet the customer's ask date. We talked about planned downtime. I mentioned that was yellow. Machines need maintenance. Tools have to be changed out. A lot of people just consider that a part of the day and don't really schedule for it. But a sophisticated manufacturer today is actually knowing how long it's going to take to change over that tool, when a machine is going to be down for maintenance, and building that into the schedule. So when expectations are set with a customer, they can be met. Our scheduling also reacts to real-time production monitoring. And by this means if a job is scheduled to take 20 seconds per part and it's actually running at 30 seconds per part, then that job's obviously going to finish later than anybody planned. And so all the downstream jobs are rescheduled to accommodate for that lateness. And conversely, if a process is running in 15 seconds rather than 20 seconds, you're going to have free machine time at the end of that, and it schedules new work into the work center. So scheduling and the ability for it to read and react to the circumstances that surround it is extremely important for getting full utilization out of the shop floor. The next piece is the actual production monitoring. And production monitoring is the lifeline of MES. It's the foundation of MES. And again, I'm always amazed at basically when you do a production monitoring, you're counting cycles, stamping press opened and closed, and how long did that cycle take. And what you can learn from production monitoring, just seeing the machine cycle, first of all, you know the machine is running, right? And you know if the cycle time is taking 20 seconds, it's running the specification. If it's taking less time or more time, then you're gonna have a change in the scheduling side. You get a count of how many parts have been made, not only good parts, but you get a count of bad parts. So if you need to make 5,000 and you just made 100 scrap, you've actually got to run 5,100 cycles to get that job done. Again, impacting the schedules, adjusting the schedules. It's all about what production monitoring can tell you simply from watching the machine run. And then something that's extremely important is the backflushing of the results of production information into the ERP. I know that I just made 100 parts. I know my raw materials inventory has been decremented by that much. I know my finished goods has gone up by that. I know how much machine time I consumed, how much raw material I consumed, how much labor I consumed, so I know my cost. I know how much of that equipment's being utilized, and I know that maybe right now we've got 110,000 cycles on that tool, and that tool is going to need to be maintenance at 120,000 cycles. My next job is 30, so I better maintenance that tool before I start that next job. All of this information comes from monitoring the basic cycle times of a piece of production equipment, be it an injection molder, or a stamping machine, or a CNC machine. Production monitoring is basic at its core, but quite expansive in terms of the value that it brings to the manufacturing operation. Process monitoring is a little bit different. Here, during the cycle of the machine, we're measuring the temperatures involved, say a barrel temperature, or we're measuring pressures, or we're measuring durations of certain activities. And we're basically writing all that down for various reasons. One, we want to make sure that the process is running correctly, right? Is it the right temperature, the pressure, does the part weigh what it's supposed to weigh when it comes off the machines? We get that information from various gauges. We get it from, coordinate measuring machines, videos, gauges, a lot of signals come out in process monitoring, and they are then written down in a historian database, which is fairly well represented by the graphic on the right. Basically, a historian database is a time series of data. So you could say you're taking measurements every 2 seconds, and you're measuring temperature and pressure. There's 2 lines on a graph stretching over the duration of the job. Those process parameters are being fed into a statistical quality control module where they can be manipulated in various ways to prove compliance, to look for root cause analysis, to document various situations for customers that are upstream. But when you do process monitoring, you may basically have proof of everything that went on during the production process, and then you've got it at your fingertips to do analysis, control, and compliance and traceability documentation further downstream. So on process monitoring, George Cave from SKF Aerospace is here with us today and has a couple thoughts on what they're doing there and a very cool manufacturing process at SKF Aerospace. George?
All right, thank you, Steve. This is George with SKF Aerospace. We work with precision rubber products for the aerospace industry. We're particularly strong in compounding rubbers for very precise load bearing and vibration explosion characteristics. One of our most important steps in our production process is the baking of the uncured rubber compound to a cured rubber assertion. The process involves not only accurate compounding, but curing at exact temperatures, pressures, and time periods. We need to monitor these parameters for each part we make. In the past, we used homegrown equipment to monitor these parameters. Sometimes we even manually recorded the data. We were limited in our ability to automatically collect, organize, and analyze data. There's a lot of manual steps and Excel spreadsheets involved. This past summer, we installed IQMS's process monitoring system in our production equipment in Chicago. Now, we automatically capture all the process parameters we need to ensure the quality of our products. All the data is automatically recorded in our historian database, and we have access to that data for downstream documentation and analysis. In addition, with our new system, we can receive automatic alerts if a process is running out of tolerance. Our new process monitoring solution with IQMS saves us time and money, and most importantly, helps us build the quality products our aerospace customers require.
So there's production monitoring, there's process monitoring, and then next comes maintenance, repair, and operations. We're going to talk about something called OEE in a second, but I've got machines, and there's various things going on with those machines. One, they need to be running correctly, and two, the tools inside of them need to be maintenance and taken care of. So that's all about scheduling for that kind of, knowing in advance that it needs to be done, scheduling it into an opportune moment, and then making sure the machine has the maximum available uptime, which is a key component of OEE, operational equipment effectiveness KPIs. We want to avoid unnecessary repair costs because we ram the thing into the ground rather than maintain it when it should be maintained. We do that by keeping track of the cycle counts, both at the machine level, the hours of operation at the machine level, the hours of operation on the tool. All that gets fed into the scheduling subsystem, so we work around when maintenance needs to be done. Also, there's facilities there to maintain the parts inventory for the equipment. If you have test spares or various tooling on hand to make repairs, there's a separate inventory module for the maintenance. And by doing all this, it's like taking care of a car. You're going to prolong the life of that equipment, and you're going to get better productivity out of that equipment along the journey. So we've talked about MES, and MES is really all about driving operational equipment effectiveness. OEE, that calculation is a fairly straightforward calculation. We've got the availability of the equipment. Is it up and running and able to produce? How are our cycles running? Are the times on plan? And are we producing good parts? So you add those three together, and what we look for is a score of greater than 90% for the OEE operational KPI. So OEE, how do we drive it with MES? Well, we monitor and we identify deviations, either from product specification or from cycle time. We make sure that the orders are teed up and we've got all of the manpower, equipment, and raw materials to fulfill that order. We keep track of the process variables to make sure we're making good parts. We watch production performance to make sure we're running on time within specifications. And we're always looking to drive cycle time down and reduce scrap. When you put all that together, you get good cost and machine ROI. So again, OEE is an excellent MES KPI, production KPI to use in your shop. It's more popular, I think, today than it's ever been. Quality is another strong dimension of MES. At IQMS, we have basically three quality packages. Quality level 1 deals largely with material review board and engineering changes and corrective action reports. Quality level 2 is a little more automotive focused. The APQP, the advanced quality planning, the PPAP, the production part approval process, and the failure mode effects analysis all come in that quality level 2. I talked a little bit earlier about SPC or statistical quality control. With the machines being production monitored and process monitored, all of that raw data is being fed into the quality packages, particularly the statistical process control package. And you can look at the trend lines in the historian database, see if they cross any boundary conditions. You can take one trend line and lay it over another trend line and look for deviations. And for your customers and regulatory people, you've got complete history of what happened during the production of those parts. All of our quality modules go towards maintaining your certifications, your ISO, your CFR Part 11. All your certifications are supported by the quality package. Early on, I mentioned we sell MES or provide MES in two different ways. One is native as part of our ERP package, and another way is through a company that's already got a third-party ERP package like an SAP or a JDE, and they want a strong shop floor management package. In that case, we do what's called an integration of the MES into the ERP, and at its simplest level, that starts with work orders and skeleton bombs, so we know what we want to work on and we know what we're working on. We run the MES just like it was native. All the previous slides are in play. And then at the end of that, we backflush the production data to the ERP. And to do the integration, both the inbound integration of the work orders and the outbound integration of the backflushing, at the simplest level, we use flat files. In a little more interactive sense, we use APIs. And then in a fully interactive sense, we use the IQMS, which is our cloud level connector of things between our ERP and MES packages to third-party software packages. That can be MES talking to ERP. It can be Salesforce talking to ERP. There's a lot of things that IQMS makes happen. Just a reminder that money is made on the shop floor, whether it's with native MES or whether it's with an MES that we've integrated to a third-party system. So key takeaways from today. If you notice production monitoring, process monitoring, it's really all about inspecting what you're doing. And throughout the entire process, people respect what you inspect. So the more they feel like things are being recorded, being watched, being cared about, the better job everybody does. Clearly in the industry, we're seeing demand for increasingly timely delivery. Shorter lead times are becoming more and more common, and quality and compliance demands are on the rise. I think if you talk to all the good manufacturers that I know, they will tell you that the more they deliver on time with high quality, the more business they get from their customers. And one of their key growth strategies is to continue to push the quality and the delivery metrics up. Real-time connectivity eliminates manual labor and errors. Several years ago, people would write all this information down on clipboards and keep track of it and maybe key it into a spreadsheet later. But there's a lot of errors that go into writing things down and doing dual data entry. So our real-time connectivity eliminates that manual labor and eliminates those errors. And then, once again, the key takeaway from all this, our philosophy here at IQMS, our philosophy, particularly in regards to MES, is that money is made on the shop floor. So for a little bit of an outside look at Industry 4.0 and IoT, I've asked Patrick Treverman of LNS Research to say a couple words. Patrick?
Thanks, Steve. This is Patrick from LNS Research. LNS Research is an industry analyst firm that is completely focused on industrial transformation and IIoT technology. And our research shows that this massive market shift going on, called IIoT or Industry 4.0, is driving a spike of interest in other digital factory technologies as well, including manufacturing execution systems. Modern MES solutions can be an important building block in a company's IIoT strategy.
So thank you all very much. We're going to do a Q&A session here next. I believe Liz will moderate that. Liz?
Thank you, Steve and George. Great job. It was a very informative session. Going into our Q&A, our first question is, are there specific types of PLCs that IQMS interfaces with, or do you have to use IQMS equipment?
We use the PIMU 88, which interfaces with everything we have, and we have probably 4 or 5 different types of machines on the floor, and we are able to bring the data source in no problem. So we have yet to have an issue where it was something with the PLC was not compatible with IQMS.
And I would add to that, for those who are listening in, the PMIU 88 is an IQMS PLC that we provide to our customers who need that last mile connected.
Does IQMS connect with industry standard PLCs?
Yes, and frankly, I'm not totally knowledgeable on all the model numbers, but I talked to Trevor, the engineer involved in this project, and he says we currently connect to over 220 different types of PLCs. That must be different models and generations within the major players, but it's a real broad scope.
Okay. Can a customer use both production monitoring and process monitoring together on the same system?
Well, absolutely, yes. A lot of people start with production monitoring. George is not one because of his process is kind of unique, but most people start with production monitoring to get a handle on work output and then grow into process monitoring to handle the exact process variables that are going on during production. So it tends to be an evolution for most people, but George, in this particular case, is strong on process monitoring, and I don't think does production monitoring. Is that right, George?
We do not use production monitoring, no. We are required by a lot of our customers to validate our process, so that's where we needed to start with. And honestly, the process monitoring is a great step into getting your controlled environment a lot more accurate and with alarms going off and letting you know when there's an issue right away in real time as opposed to finding out later after a shift or after a quality inspection point.
Perfect. Liz?
Okay, next question. How would this work for an assembly process as opposed to a machine run process?
We're talking about production monitoring, right? And not process in that particular case. And a lot of what we do in assembly is hand signal that the step has taken place. So to put it simply, there's a clicker involved, and the operator clicks it when they've passed a particular step, and that is recorded as a production cycle.
Is it required to use the quality modules with the monitoring system to derive the benefits you described, such as MRO and OEE?
Is it required? No. Is it pretty much the most straightforward way to go about it? The answer to that is yes, because the data flows are native and the professional service people know how to set it up that way. And it becomes a turnkey solution as compared to something where you have to involve a third party or a third piece of software.
If I can chime in on that, having the OEE modules and the other data readily available at the real time makes reporting a lot easier when you have to report up or even daily for your production personnel to know where their OEE is at and where they're standing is actually very helpful, not have to sit there and crunch numbers and give them information right away.
Good information. Can I access this information from various tablet operating systems, Android, Windows, iOS?
George, I'll let you answer how you're doing it first, then I'll answer.
Well, we use the Android servers with the RT stations, which connect to the PMU88, which is an interface for the operator at the machine. They're able to enter data, enter everything from scrap to the way it's running, and they can see their limits that we have set on the process they're running. I can access from my PC. I can access from an Android tablet that we use now, and that's usually how I'm doing that. I'm sure there's more functions I haven't even learned about yet, but I'm sure we'll get there at some point.
So, and I echo George's answer. You can access it from, I won't say any device, but almost any device. It's an open system in that regards.
Great. Thank you for participating in our webinar series.
I wanted to thank George one more time for participating. Thanks, George. Good job.
Not a problem, and thank you guys at IQMS. Appreciate it.
You guys.
All right. Take care, everybody. Bye.
Thank you for viewing this pre-recorded webinar. For more information on DelmiaWorks products and services, please visit IQMS.com.